Happening. Cool. Hey everybody, welcome back. Yeah, today we are escaping the curse of recursion and talking about iteration, which is like how you'll actually probably do most things in like with computer science. Which, yeah, that's kind of an exciting change. It tends to be a lot more easy to conceptually just get because you're basically just doing something multiple times, and I know how many times you're doing it. Yeah, so we're also going to be doing a little bit more stuff with Turtle, so it'll just be kind of hopefully a pretty simple day as usual. Ask questions if you guys do. And follow along. We'll be doing a lot of some live Python stuff as we go. Feel free to plug along on examples yourself, and yeah, it should be good. Bigger. All right, so still working with Turtle. Still love this adorable image. I'll recap from yesterday or Monday. Yeah, so Python has this awesome Turtle program. What channel here? Again, kind of make big. So for a Mac, we can just type in Python from a terminal window. On PC, we have to kind of go into command prompt and go to that. Find your Python directory, then type in Python. But yeah, so step one, import Turtle. And that kind of sets us up to be able to rock and roll. Change shape if you want. Turtle lead, a lady. And yeah, you can give it commands. Make them run backwards. For 50. Right. 5. Forward. And hey.
Hi.
Rocking and rolling. Oh, hey, Laria.
Hi.
So we are, yeah, just started. Just kind of recapping Turtle.
Okay, I'm gonna open the slides.
Awesome. So yeah, we're right now just kind of up on the Turtle. So recap. So yeah, if you remember that from last time. Yeah, and kind of last time we were talking about, let's say we want to draw a square or something, or some random shape. We have to type in a bunch of different commands. Basically, turtle dot forward 50 90. Benny.
Nothing.
So if we wanted to make a square, we have to do all these commands. And we're doing the same 2 commands 4 times. There are ways we can do that with recursion. Some people would say that's like the most elegant way to do it. Most people are wrong. What we could actually do is we could take these 4 lines and we can do them in what's called an iterative loop. We'll talk a little bit more about this. I'm going to go ahead and write this to get this draw square function. Get it right out. That's just kind of typing in everything out same. What's this? What's that? Square 100. Ideal little square. But especially the more complicated we get, and this is the same thing 4 times. Kind of exhausting. You can actually go ahead and grab this code. Code for a cube there. So yeah, I'm just going to kind of walk through this code line by line. So whereas this first function is super obvious, set up the function name, give it an input variable that we're going to use to just figure out how big our square is. And yeah, we just go forward by that amount, turn right 90 degrees, forward, right. Pretty straightforward, but pretty lengthy. Instead, what we can do is we can set up our function, something. Then we can just create this internal variable, it's the local variable, sides to draw. We want to draw 4 sides. And then we're going to set this while. This is something that's common in most programming languages. We'll talk about its sister in a little bit, but the while loop basically says I'm going to set up a condition, like a conditional, very similar, like our if statements from before. And then while this condition is true, this block of code, I'm just going to run this over and over and over. So while sides to draw is greater than 0, I'm going to go move forward and turn right, just like these 2 blocks. And then I'm going to say, okay, I drew one of the sides, so I'm going to take sides to draw and subtract 1 from that. So I'll draw, it'll be 4, then 3, then 2, then 1, and eventually it'll be sides to draw will be 0, and we'll be done with this while loop, and we'll exit, and draw our little square. So yeah, I'm going to break this down a little bit further. Yeah, the while basically says, while some condition is true, do something. Something will be a block of code. So, for instance, we're going to go ahead and set up this function, check password. This is kind of a simple example, but you guys remember the raw input function?
Mm-hmm.
So we're going to create this function, check password. We're going to first go ahead, the very first thing we're going to do is we're going to set up this variable password. We're going to ask, hey, ask for a password. And it's going to ask the user, and it's going to store that into password. And then the program is going to go, while password is, this exclamation point equals, is not equals. So until somebody gets the password right, the password being hard-coded as secret here, it's just going to go and print, that's not the password, and then ask for it again and store it back in this password variable. And copy this code. Let's run check password. Asking it for password. I'm going to go with banana. Not the password. So I went ahead and entered, ran this line with the password, stored it into password, and since that wasn't equal to secret, I went down to this, started running this block of code. So it printed, that's not the password, and then we're currently at this line of code right now, this 8. And I ask for it again, and it's going to wait until I give it input, and then it's going to store that in password. I might go puppies. Put it into password, and it jumped. I don't know if you guys can you see the mouse? So it jumped from here, from this, or jumped from this line. It jumped back to this test so we hit the end of this block of code. You can tell the indentations. We hit the end of this block of code, so it jumped back up and right? Basically, hey, is password equal to secret? Not. So we do this code again. We'll keep doing this code. And keep running this loop forever until it's secret, and then it exits out of the loop because wait, it was equal to secret, and so this condition was no longer true, and so it exited out. That making sense?
Mm-hmm.
Sweet. So the while loop has like basically three kind of conceptual components. First, we want to set up a variable to test. In this case, it was password. Then we'll figure out a condition that we want to test that variable against. So that goes in the while statement. So as opposed to, when we first start off, we'd be like, if password is not equal to secret, print that's not the password, and then go ahead and try again. Then it would exit out. Versus while says keep testing this until.
The while is the loop.
Yep. So it's a while loop.
While loop.
So importantly, inside the while loop, we're going to basically always make sure that the variable that we're testing, we want to change that in some way, because otherwise the while loop will never get out of it. Because if we set password to be like this, and say we hit, second try password, we set that up as this variable. Like password, as long as we didn't get it right on the first time, it would jump into this. And then password is never changing, and neither is secret. So no matter what you typed in, you'd never get this.
You'd never get what?
Or you'd never leave it.
It would just be wrong all the time.
Yeah, it would always be wrong, and you'd be stuck in this code forever. Yeah.
Password torture.
Right? So we're going to do an example. Kind of a quiz. So I've got this code. What's the test variable here?
A number of sides?
Okay.
I don't know.
Valeria?
While num sides equal to 0? No.
Yeah, so number of sides is the variable that we're going to be testing. And so what's the condition that we're going to be testing it against?
The 0 or less than 0. Or,
Yeah.
no, or maybe not the
So the condition that we're testing is whether or not it's greater than 0.
Okay.
So we have this variable number of sides that we actually entered in as one of the input variables this time. You'll see that a lot with like if you want to have a function, especially if you have a function that takes in something it takes in like how many times it's going to run that loop inside the function. The number of sides is a variable. Then the condition that we want to check is number of sides greater than 0. And finally, what's the part that changes the test variable inside our loop? Yep. So num sides equals num sides minus 1. So this is the part when we keep going, when we go through number of sides. Every time we go through this loop, we want to make sure that we take one off of number of sides. So eventually, number of sides will be equal to 0, and we can exit the loop. Yep, it's counting down.
Down from whatever number of sides.
Yeah. So we can try put this in. Instead of draw a square, we've got this generic polygon function. Pick up polygon, and I went. square. Does this making sense to you guys so far? Is there any questions? So this function, draw a polygon. Yeah. So just angle of interior angle of a regular polygon is root of 360 divided by the number of sides. Wow. So, random math nerd fact.
Yeah.
But yeah, and so it takes the number of sides that we want to draw on the side length, and then it just draws a bit, draws the length, then turns the proper angle that we want to our regular polygon, and then it says basically, oh, I drew one side, so I want to make sure I keep counting that down, so eventually we're done. So, just another example of, so we can go ahead and have a function that calls another function. What's the test variable in this one?
The sides.
Mm-hmm. So we've got polysides here. We're going to be This is going to be technically we have two here, number of polys and polysides. In this function, number of polys stays constant, so polysides is the one that we were a little bit more concerned with. What's the condition that our while loop is checking for?
Polysides.
Yeah.
Polys.
Yeah, so we're checking to make sure the number of polysides is less than or equal to the number of polys. Then we just use this graph polygon function that we wrote last and give it a slice. And then we're gonna add one to polysides. So polysides is gonna start at 2, just so it'll draw a line back and forth, and then it'll go to a 3-sided polygon, and a 4-sided polygon, and a 5-sided polygon, all the way up until with the number of polygons that we want. So let's just start that at 3 to be clear. Grab column. Let's reset this actually. Put 10 of them. Good. I draw up to a 10-sided polygon.
Oh.
Draw polygon. I did not copy this detail. Oops. Triangle, square.
Oh. Cool. So just gonna keep doing it until you reach 10.
Yep.
That's gonna stop. That's
Exactly.
so cool.
And so where we talked about kind of division errors, you see that it kind of winds up getting a little skewed here. It's going to be because the probable reason there is that I would guess that's probably a integer division. Because we're doing integer division here, and sometimes that winds up not being evenly divisible into 360. See if we get that, change that. Let's see what happens if we add 0 in there. Yeah, it looks like that one's being a little bit more precise because we don't have the integer
turtle.
division screwing things up. So, pattern going. All right, so go ahead and the difference between this code and this code is that on here, let's say I forgot to go ahead and limit my text. So we just say, okay, well, draw poly sides is less than number of polys, draw polygon of number of sides. I'm not actually changing this. So all this is going to do, as long as number of polys is greater than 2 or 3, it's going to get stuck in this.
It won't stop.
We're kind of overwriting our function. We go. So draw polygons and again. We get stuck here. I'm just going to put him off the set while I talk more. So all he's doing is drawing this polygon with sides 3. This never changes. So it never gets to be greater than number of polys, and so he just marches on that triangle from now until forever. So this is going to happen. You are going to do this. I have done this thousands of times. Written code that winds up stuck in an infinite loop because I screwed up. I was not thinking right. I got confused about a variable, and it was iterating weird things, so this goes forever. So how do you fix this? So this is a keyboard shortcut in Python, and in general for running things from a terminal, and even if it's not Python, hit Control-C or Command-C. It'll be a bunch of garbage that throws up, but the most important thing is at the very bottom, it'll say keyboard interrupt. And it'll give you some traceback information. So notice like when we draw polygons, or if a broken code drawing this, that's a fun thing since it's kind of a little bit. We wind up with, so it's just, we're not getting, I can type some stuff in here, but it doesn't do anything. It's ignoring this input. And it's up. That's it. Nothing in my code says, hey, listen to keyboard. So I can tap on it all day, and it doesn't care. And it's not going to release control of this terminal window. I can't do anything else. Python, I can't call polygon. Nothing here is doing anything. So I have to hit Control-C. It gives me this traceback, and this tells me where in the program I stopped when I hit this keyboard interrupt, and then just a bunch of gobbledygook. So it's basically saying, okay, you stopped. This was like the last line I was at. This is the last line. This is the last line. So when I stopped, I was in line 1 of drawing something. I was in line 4 of draw polygons, which was in line 5 of draw polygons, which was in line 1 of the left function, which was in the system.library. Total.py is this line, which is the self.rotate, which called self. So as you get more advanced on this callback string and get more useful to you, it generally tells you where in your code shit started going wrong. You can ignore it for now, though. Eventually, run into enough other things that screw up and you'll kind of start piecing together. Oh, hey, this gives you some hints about where things went wrong. Yeah, it just stopped and the turtle's here, so one thing is the turtle is here, let's still actually hang around so I can just start drawing it again. running on with them again. Yeah, so code starts running uncontrollably, Control C. You can also just like probably move down the terminal window and it'll probably be like, hey, you're still running something, but close that out. So I'm still gonna try that. I'm gonna start him running forever again. Slightly different angle because he's rotating while it's not stopping. Close this. Yeah. Closing this window will terminate the running process as Python. Close that and it shuts down everything. Yeah. But now I have to go ahead and I just lost everything, so I need to put everything back in. So I gotta import, turtle, I'll make it bigger, import turtle, okay, functions back. Turtle. Hooray! And we're back.
Chatham,
What's up?
why would you use Control C in that scenario as opposed to just reset turtle?
So you have to use Control C because it's not listening to you. So I'll go ahead and
Stuck in the loop?
yeah, when you're stuck in the loop, you can type in commands and it doesn't care because it is not interpreting them. So when we have the caret, the 3 carets here, it's saying, okay, Python's saying, okay, I'm ready, I'm listening for commands. I'm ready to go. But if we go, so we're gonna start our infinite loop again. Okay, drawing is forever triangle. I can type in reset. Doesn't do anything. So the Python interpreter that's sitting here like actually running commands, it's saying it gets this and it says, okay, I'm going to run all of these commands that that you told me to run, and it's not actually listening to anything here. So
It hasn't finished completing its commands. It's just not going to listen to anything that you want to feed into it next.
Yeah, so the Python interpreter says like I'm going to run one thing after the next, and like okay, like well I'm never going to get to this. So
Okay.
So we have to tell the Python interpreter like, hey, stop what you're doing.
Yep.
Which is Control C.
Okay.
Notice it didn't do the reset at all. This is just basically free space. Like, I mean, I can type in Moby Dick. It's going to wind up lost for forever. Doesn't do anything. Doesn't help us out.
Yep.
Yeah, so this is going to be a handy command for you in life in general. If you're ever on the command line, both processes. If you're trying to run something and it's stuck and like it's kind of the program's locked up, Control C will generally try its best to end what's running in that terminal window. Kind of like it's a force quit basically. Yeah, so the two places in general where your while loop is going to wind up being stuck and moving into the loop. So the first thing that we checked out, this last bit of code that we were writing was, did you remember to change the variable that you tested? So in this one, so in this, here where we're adding 1 to polysides to make sure that eventually polysides gets up to number polys. Well, when we deleted that, polysides just hangs out at 3 forever, and our code runs forever. The other way you're just going to screw things up is that the test is not going to make sense. You're going to write a test that you think that it's going to end, but just because of the way that you're kind of adding things together, or let's let me make this a little bit more. I'm going to turn this into a double equals 3. We're going to increment by 2. I'm going to draw every other polygon. So I'm going to go, let's say, well, it's not equal. So eventually, we think that, we're going to run into number of eventually polysides will equal the number of polys and we'll stop. So that's our thinking here. We're going to figure that's going to work. So I wish I hadn't had this long of a name. So let's draw every other polygon up to 9. Our triangle, our pentagon, a septagon. Oh, hey, and we drew them everyone up to 9. It stopped. That was great. Now what happens? Let's see if we go up to hexagon or whatever. Go ahead and reset this. Yeah, so we had our group variable, and this time instead of adding 1 to it, we're adding 2 to it. Let's go ahead and let's go ahead and test it with 10. Got that dude, get that dude. Oh, so we get the 9-sided. That's we should have stopped by now.
Oh, yeah.
Let's keep going. That seems like that's definitely more than 10 sides now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah.
Don't take that into account.
Yeah. So what's going on here? We're gonna control C. I don't want to do that. This is where print statements come in super handy. Go ahead and keep 3 sizes. 2. So doing, and then turn this to a star equals name. Sorry. So I hope you trust this. There's the same functions. There are differences, so the turtles, going out of control. So let's go run it again because it's like it's almost done. Pretty little regular polygons, and he's just not stopping. So I can do this forever. So that's obviously not doing what I want to do. So I'm going to go ahead and add in this print polyside. I want to see what the hell's going on with my polysides because I think there's no, like, I'm adding numbers of polysides. Like, why isn't it ever triggering this condition? So I want to actually figure out what the heck polysides is doing. There we go. I'm going to draw every other polygon. That did 3, did 5, did 7, did 9, did 11. Oh, I see what's going on. It's not hitting 10, and that's why it's not Yeah. That's a fairly simple example here. You might be able to just walk through on your own. Okay, we started at 3, added 2, 5, 7, 9, 11. This needs to be, what's less than or equal, or maybe just less than instead of what it's equal to.
Oh, so it's less than 10.
So less than whatever we put in. That's that's definition. So put the not equals here and add 2 plus equals. Yeah, so is that making sense in this strategy for figuring out why things are broken?
Mm-hmm.
Awesome. Print is the gift that program language designers give to you. One thing that makes this doable. Figuring out what the hell's going on inside your program, because otherwise it tends to be kind of a black box. So I want to talk about Miles got a friend. My name's for statement. I'll talk about this a little bit later on the slide deck. You will, outside of Python, you will run into for a lot. I almost never see while in the wild. I almost see for loops. And they both do the same thing. They both run a block of code in a loop. It's just kind of the way that the semantics and the kind of the pattern that we use is slightly different. Yeah, it can kind of simplify things, and especially Python kind of uses it for a specific case, actually. So we'll go ahead and run a 91-sided polygon. That's pretty exciting. 93-sided polygon. Look at him go. We're going to go ahead and start. White space. Yeah, so we were using those while statements. So this is, again, I've got this. We're going to define our function, print numbers up to whatever top numbers. We have this function that's going to print a bunch of numbers until it hits the end, it hits the maximum number that we give it. So we're going to create this loop variable, number, or num, set to 0, and while num is less than or equal to top num, less than. We're going to go ahead and print num, and so this is our kind of loop variable. This is our conditional that we're testing, whether or not it's still less than top num. And here's where we change it, so we don't get stuck in an infinite loop. Control V. So go up to 5. So 0, 1, 2, 3, 4. Then number is 0. It's less than 5. From there, so we printed it and we added 1. So number was 1. Still less than 5. So then printed it. Number 2. Still less than 5, all the way up until number was 4. Still less than 5. Printed it. Then number was equal to 5. So it wasn't true. So we exited. Broke out of the loop. Finished up. We have this. We also, in addition to the while statement, we have the for statement. And in Python, what for does is it walks through a list of things. So this code also print numbers up to. I'll paste that just so I have it. It says for. The pattern with the for statement in Python is the word for, then you give a variable name, then the word in, and then you give it a list. In this case, so range is a built-in function, which gives us a list from 0 to 1 minus the second number that we, 1 minus this number. So if we just type in range 0 to 5, we get a list, 0, 1, 2, 3, 4. So what this code is going to do is it's going to say for every number in this, or for every element in this list, which we'll do that, we'll go ahead and print that. So it's kind of basically saying, okay, we're going to do this code once, we're going to run through this code once for every element in this list. And we're going to call the element in the list, in this case, num. So I'll say that's 0, 1, 2, 3, 4. But it says, okay, let's first take this first element, which is a 0, put it in. So for this first round, num is going to equal the first element here. So it's going to print that. And then it's going to come back to this. And it's going to say, okay, we're on to the second element in this, which is a 1. I want to print it. So the general, this is for each element in a list, it it runs a line of code. In this case, it would be for every element in whatever list you have. So this is a variable again. So a list. So we're going to print list is going to take in a list as a variable, and it's going to go through every element in list. It's going to call that element for the purposes of this block as a print element. So I could be like print list. Let's do each. And go back effort. List. I went through each element in this and figured it out. Because of this, it's not. I would probably recommend using while loops more than for loops in Python, just because it's kind of got this complexity. I'll talk a little bit more about it. So one thing that's useful is that range function. So that just gives you a list of numbers. Which is super handy when you have a list of things and you want to call them by index. So like if you want to actually like change something that's in a list, you can have this like appending to list, which is going to go for index in range, which is the length of the list. So put 0 here. So we're going to get a list that's going to have all the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up until the length of whatever list we put into it. And it's going to go, hey, so list index 0, and then index 1, index 2. So real quick. And then to the list. It's going to take in a list and it's going to take in a string. It's going to take in name. It's going to add apostrophe s, and then it's going to add it to whatever was in the list at index 0, then index 1, then index 2, and so on and so forth. So I'm actually going to throw in some print statements to make this a little bit more. So yeah, this code went through and changed index to be 0, then 1, then 2, and then looked into the list index. From the beginning, so change your fruit list. Or fruit list.
Let's read.
So it did this.
Wait, you just did this?
It did this whole block of code for everything in this.
I don't even remember what this. Sorry, I was just thinking about. I was just my mind. I was trying to work out what the difference. This is iteration, right?
Iteration.
Getting stuck in a loop, and I was trying to figure out what the difference of that stuff to version. And I had to work on that for a while. And all of a sudden, I don't know what was going on. That was.
So I'm probably not going to ask you guys to do much with it before, because it's kind of weird in Python.
Should
For
with
the
the
for
while,
loop.
with the while maybe.
I'm kind of going through it because so you will see for a lot if you switch to a different language. I'm going to explain that in a little bit. Do you want a sidebar on function compositing? So functions a lot of times return things. And you can use those. So you can use that like function call statement as an actual input into another function. Then it'd be really common. So you're going to have this like list and a test list or fruit list. You can go. I forgot the length of fruit. Fruit list 3. So you want to start to create a variable list size of the length of fruit list. Now list size is 3. You can get a range from that would give us 0 through that. So you go like range list size. You might write all of that out. To get to basically get set of indices or whatever, 0, 1, 2, 3, all the way up to however long the list is. You could also just basically skip out this whole like list size stuff, because you're basically saying, okay, I'm going to take the length of this stored into list size, then run the length or range function on list size. So you can actually just go range and input into that length of fruit size. So we're calling a function because this function is going to run and return a value. We're going to stick that value directly into our range function. Right.
Oh, okay.
Yeah, sorry about that. So again, I screwed up with fruit size that doesn't list. So we have this fruit list, and we want to take the length of it and pass that into the range function. So we're going to have this function that's returning a value, and we're going to give that return value straight into the input of our range function. Awesome. So,
I'm
do you have a
sort of.
this? Yes.
It is.
So this is actually a super common use case. Like something like in SubML, like if you're doing anything in processing, for instance, this won't actually go through, but like if you want to get the size of a list in processing, you might have like my list variable and you run like that size. I'm giving an error, but that'd be a way that you would get like how big your list is. This would be if you're running but like so if you're working in processing, then you might want to have some sort of variable that would, if it had some like a range function that would take in my list that size. So this would be the same thing as this function, just in a different language. If you want to kind of start, you do this a lot with something like size or built-in functions like this. Don't get too crazy doing this. I mean, you could put as many functions inside other functions as you wanted to. That tends to mean that you probably should like reorganize your code, just because it's going to be really hard to read and really confusing. It tends to be a trade-off between like the number of lines you write and how easy it is. So the more lines you write tends to be easier to read rather than just having like one big massive long line that does everything. But you will see, people run things like range on fruit list. So you use that. I mean, it's a powerful tool, especially with things that rather than setting up list size equals the length of fruit list and range of list size. Just compact that into one thing. It's easy to understand. Basically, think about writing code is the way you write sentences. try to keep things simple, and if you're adding 10 commas in your sentence, like probably need to put in a period and enter a new line. Lines of code are kind of like sentences. They should say something, but keep it fairly simple. Yeah, so I was talking about for is a little bit unique. For is really designed in Python to map. It's known as mapping functions over lists. So the idea with Python is like we have a list, a variable that has a list in it. Then we want to do a line of code or a bunch of lines on code on every element that's stored in that list. Maybe we have a list of prices and we want to calculate tax on all of them. So we might have a function that says, okay, for every price in price list, calculate tax, and you add it to a separate list.
So that's what it's really meant.
Yeah.
Do something.
Yeah. So like for is really pretty specific in Python for doing things over lists. But to be honest, a lot of times that you use a for statement or a while statement, you're in other languages. A lot of times you're using it to iterate through a list. You want to do something to every element underneath. So let's say, for instance, in my beautiful face. Yeah, so for instance, if you are programming and processing, you have direct access to every pixel on the screen if you want it. You have this array, which is a type of list called pixels, and you can individually address every single pixel on your display. So you might want to be like, okay, I want to take every pixel and I want to invert the color on it. So I would write a function that would probably a for loop that would be like for each pixel in this big array of all pixels on my screen, go through each pixel and invert the color on it. So that would be a so there are a lot of times that you will use for and you also use list if you're outside Python, but it's also really convenient being like, oh, now I'll show you guys real quick. So if I was going to get a tattoo, this line right here is a strong contender.
Where would it go?
Yeah, that's a good question.
Lower back top.
Right. Yeah, I'm going to tramp stamp this.
Tramp stamp that.
For int I equals 0, I less than array.length, I plus plus. That's going to be what I'm going to drunkenly get.
I'll pay for it, Chatham, if you actually get that.
Whatever. So I'm actually going to say this, but this line right here, where should go? Hi, Devin.
Remember it's probably gone.
Yeah. Whatever. Yeah. Okay, we're back. Yeah, so in Java and in C++, so Java is processing. If you're writing that, which is super common for creative coding, that's just writing in Java. If you write in Arduino, you'll be using C++. If you do coding for the web, you'll write in JavaScript. A lot of other languages, so just like the C family of languages, or like C Sharp if you're running on Windows. Probably Objective-C on OS X probably is very similar. Uh, yeah, so in Java, the C way of doing this is this for statement. So you set up your loop variable. These languages are also like known as statically typed, which means you have to tell it it's an integer. So we have this integer for integer I, and we're going to set it equal to 1. And as long as I is less than the number of iterations, we're going to do this I++, which is the same thing as I plus equals 1. We don't get plus plus in Python for some reason. A lot of other languages get plus plus. It just means add 1 to something. So like C++ is kind of a play on the C language that's like, oh, C plus
But
1.
plus 1.
Yeah.
Oh, I see. Like slang now.
Yeah.
Plus
yeah.
plus.
So this line of code is like if you want to do anything in a loop, this is what I always use. This is what I would say 99% of the time I see a loop, it's a for loop. When I'm in processing, if I'm in Arduino, if I'm in JavaScript, just because it like puts everything rather than having so there's the while loop. So the while loop, you have to keep track of this like number of sides variable or this sides to draw. We had to set up this variable here, and we had this while statement, and then we had to remember, hey, make sure I keep changing my loop variable so I don't totally screw everything up. The for loop in these other languages, you set up your loop variable, you set up the condition, and you tell every loop, okay, add 1, or this could be plus equals 2, or whatever. There are a couple of different things you might do. But yeah, it says, basically take I started at 0, add 1 until it's equal or greater to the number of iterations, and then like do something with it. So it's basically, number of iterations. If I want to do something 10 times, I'd just be from I is equal to 0, I is less than 10, I plus plus, I'll do a 0, then I'll do 1, then I'll do 2, all the way up to 9, and that's 10 times. Even if I don't even use the variable I. This just does something 10 times, and it's fantastic. If you want to play around with that, basically the way to get that pattern in Python would be for I in range of, let's actually go ahead and operations. Paste that. Number iterations. It means if you don't have a 0, range will just take in one thing and it'll automatically move you from 0 to whatever. You go from I in range 0 to number of iterations. And this would give you I that's going to be 0, and then a 1, then a 2, then a 3, then a 4. So, let me copy that code. So it's going to print out 0 through 9. So, if you have any experience, if you've done mucked around with for loops in Java and processing, this is how to get the same code block as this. So it's an easy way to kind of be like, okay, I want to do something number of iteration times. But like I said, the while loop in Python makes a little bit conceptually easier to follow. They do the exact same thing. Anything you write in a for loop, you can write with a while loop. Similarly, anything you write with a while loop, you can write in a for loop. I'm not really sure the history of why that is. But yeah. But yeah, I mean, kind of one of the things with mapping functions, we kind of talked about Python's kind of weird. So for is designed in Python to map functions over lists. To wrap things up, sidebar. So back to high level computer science. MapReduce, basically, this is why the internet works the way it works today. Basically, this is the concept of map and then reduce, which I'll talk about is here. This slide is like Google MapReduce, and it's like an algorithm, which is basically just kind of a high level like instruction manual of how to do something. This is how we work with big data. So anything that we want to do, so something like Google enters the entire internet. It has a bunch of computers that are sitting around and indexing all these web pages and searching for terms and creating these big databases of where to find catnip. So searching the internet's like kind of a complicated thing. I mean, you can't store the entire internet on your computer. Search through it. It's way too big. You can't just say, okay, I'm going to have one computer and I'm just going to like start searching the internet on this one computer. It's going to take forever because there's so much in it to do. But if you had like a million computers, you might be able to like start crack that. And what you can do is you can basically have a bunch of computers, each search a little part of the internet. So basically, imagine all the web pages on the internet as one big list. And so you can actually just like, or let's divide, each 1,000 pages on the internet as, let's have a list, and each element in the list is 1,000 web pages. So you could have a function that searches through 1,000 web pages for something, for catnips or for whatever you put in. And then you can map that list of all these like 1,000 web page chunks. So in this big 1,000 web, so you can map that function against that and have a separate computer running that function. So you could have 1,000 computers, or however many computers it takes. Each computer only has to look at 1,000 web pages. And so you get all these computers that all have their little sub list of which of these 1,000 web pages is talking about catnips.
What happens when pages increase?
Add more resources, add more computers, search longer.
How many pages on average increases every day?
I mean, 1,000's just throwing a number out there.
Yeah,
on each.
no, I know.
But and so you wind up with all these like sub answers. Okay, 1,000 pages. I have this. And computer A has that. Computer B has this 1,000 pages. I have this many websites. So you have this reduce step, which takes all these like sub answers and compresses them all together and gets like one final answer. So it's kind of, you take your problem, you split it up into a bunch of parts that are all independent from each other, and then there's big list of kind of these sub-chunks, and then you map your function across all the sub-chunks, and so you get a bunch of sub-results, and then you reduce them all together. So it's just kind of an aside to like take a problem, break it up into a bunch of smaller chunks. So the big thing is it's basically doing all the searching in parallel.
Yeah.
Yeah. So it's like having.
I guess build one thing, pass it out.
Yeah.
But it's like.
Something like if you had to paint all the rooms in your house, you could have one person paint all the rooms, or you could hire 5 people to all paint one room. Yeah. So yeah, this is kind of a sidebar. So MapReduce is a super powerful concept. It basically has allowed the internet to work for the last 20, 25 years. And when you want to start working on big data, if you want to start messing around with that, it's being able to break your problem down into these little sub-chunks and assign those sub-chunks out to different computers, different processors. If you're doing things in the cloud, a lot of times the cloud, like on like Amazon Web Services, it'll like break through automatically the power of Amazon Web Services. So, like, you can easily work. Like it automatically scales up however many computers like you kind of need to like break your problem up into a bunch of different chunks, and they can all run in parallel and then squeeze it all back together and get your code like way faster than just having one computer going through your giant amount of
One has on a daily basis.
So, yeah, so that's everything we have for today. Basically, I'm going to try to send you guys some homework tomorrow, probably. But it's basically just going to be, like I said in the email, the homework is just going to be like use some for loops, basically get some functions that draw cool stuff with Turtle, and make some functions that make some like higher level functions that call like, write some like lower level functions that maybe like draw a line or like draw a couple of lines or draw a square, and make a couple of functions that call those smaller functions to make like a bigger thing. And then write a couple of functions that use loops and to draw things repeatedly. And for extra credit, do something that involves recursion. A great example, I can pull it from the CSI website, like drawing trees. So having a piece of code that says, okay, draw a branch, then rotate, draw draw 100 a branch that's 100 long, which is your draw branch function would be like draw a branch that goes 100 long, then turn left a little bit and call draw branch again, and come back and go draw branch to the right. So it's kind of extra credit. If you do a lot of if you want to ever do anything that's like fractal, recursion is where you're gonna want to go. If you hate fractals like Jenny,
I do, and it's like that's all the doors do.
if you want to make Jenny happy, don't do the extra credit.
Maybe do a fifth fractal. That would really make me happy.
So, yeah, do you guys have any questions? Is this kind of more straightforward? Is this making sense?
Yeah, it makes sense.
No, but yeah, I think it's a matter of doing some exercises and
Awesome.
check.
I mean, basically, the while loop is saying, while this condition is true, do this over and over until that condition is not true anymore. So it's kind of the overall system. And yeah, I'll give you a bit of these examples in the slides. If I can write some more examples, that'll help. Shoot me an email. Yeah. So, well, thanks for showing up as usual.
Cool. Thanks very much, Chatham.
Awesome.
Yes, thank you.
Thank you, Chatham.
Take care.
Bye.